So as with many things in mathematics, we have some notation for functions, okay? And all this notation is just really a way for us to write things concisely and quickly, okay? Um, so we often denote functions by letters, okay? F, G, it could be capital or lowercase. Um, H, almost any letter we can use to represent a function. Okay? If f is a function, okay, then for each number x in its domain, the corresponding image, which remember is the output in the range, is f of x. So if x is the input, f of x is the output. Okay, and we do read this f of x or f at x. Okay. So sometimes when we're talking about f of x, that's the value of f at the number x. Okay, so you know f of 3 is the value of f at 3. Okay, or we call it the output corresponding to x, or we refer to it as the image of x, which we did previously. Okay, important note: f of x is not f times x. So please do not talk about that as f times x or g times x or whatever the function happens to be. Okay. So let's look at a few examples of finding values for a function. Okay. So if we're defining this function f by f of x equals 2x squared minus 3x. Okay. So here's our definition. X is our input. F of x represents the output. Okay, so we might also write that sometimes in the past we could write that as y equals 2x squared minus 3x. Okay, and so f of x and y are often interchangeable. Okay, so y is equal to f of x. And we can even talk about ordered pairs. We've talked about x and y, but we can even talk about them as x and f of x. Okay, again, just some notational items, so don't be confused if you see this sort of notation. So we want to evaluate f of 3. Okay, so all we do is we are going to substitute in, okay, everywhere we see x, we are now going to substitute in 3. So f of 3 is equal to 2 times 3 squared minus 3 times 3. Okay, and then we can evaluate that, and that becomes 18 minus 9, which is 9. Okay, so we would say that f of 3 is equal to 9. So that's A. Let's label that. So B, let's look at B. We have f of x plus f of 3. F of x plus f of 3. Okay, well, f of x is just 2x squared minus 3x. And note that we've already defined f of 3. So f of 3 is 9. So f of 3 is 9, so we can just plug that in there. So f of x, that's f of x. So f of x, let's do that in a different color. F of x, that's where I got that. F of x. And then f of 3 is 9. We'll call that f of 3. Okay, and so I just get this expression. So f of x plus f of 3 is equal to 2x squared minus 3x plus 9. Okay. And so we can look at the next example. We have 3 times f of x. And so I encourage you maybe to pause it and see if you can work this out for yourself. And so 3 times f of x is just going to be 3 times 2x squared minus 3x. Okay, again, we're just substituting in this value for f of x, and we can simplify that and say that is 6x squared minus 9x. Okay, so 3 times f of x is 6x squared minus 9x. So let's take a look at a few more. D is f of negative x. So now everywhere we see x in our function, okay, we are going to replace that with a negative x. So you have to be careful with parentheses and such here. So I get 2 times, instead of x squared, I get negative x squared minus 3 times negative x. And so if I simplify that, well, negative x squared, anything squared is positive. Okay, so negative x squared is equal to x squared, so that becomes 2x squared still. Now minus 3 times a negative x, so 3 times a negative x is going to be like 3 times negative 1x, and 3 times negative 1 is just a negative 3. Okay, so I get negative 3x, so I get minus negative 3x, which is plus 3x. And so f of negative x, or f of the opposite of x, is 2x squared plus 3x. Let's look at E, negative f of x. Okay, so that's just the opposite of f of x, so that's just the opposite of 2x squared minus 3x. And again, parentheses are important. You're taking the opposite of the entire thing. Okay, so this is like having a negative 1 out front, and if you distribute that negative 1, okay, it's going to change the sign of everything in there. So this is going to become negative 2x squared plus 3x. Let's see if we can fit these all on this screen. So f of 3x. This is f to f of 3x. And again, now we are just replacing everywhere we see x, we are going to replace that with 3x. So this is equal to 2x squared, but now it becomes 3x squared minus 3 times 3x. So everywhere I see an x, I'm replacing it with 3x. And I can simplify, and that becomes 2 times 9x squared. So 3x squared is 9x squared minus 9x. And 2 times 9 is 18, so 18x squared minus 9x. And the last one, G, is f of x plus 3. Again, everywhere we see x plus 3, okay, or everywhere we see x in our original, we're going to replace it with x plus 3. So I get 2 times x plus 3 squared minus 3 times x plus 3. Okay, and now we can do the algebra and multiply this all out. Okay, and so if we do that, we first have to expand this. So this is x plus 3 times x plus 3. Okay, so you're going to FOIL that, and I won't do it here. Okay, I won't go through that step here, but you're going to multiply x plus 3 times x plus 3, and you should get x squared plus 6x plus 9 minus 3x plus, minus 3x minus 9, because you've got the negative 3 times x, and you've got the negative 3 times 3, which is a negative 9. And so we can distribute the 2. And now we can combine like terms. 2x squared. We have a 12x and a 3x, so that becomes 9x. And then we have the 18 and minus 9. We get plus 9. Okay, so that is our simplified version. Okay, and note, guys, that we really can work with this version, and unless for some reason we needed it in this form, which we might, like if we want to solve with the quadratic formula, we would need to put it in this form. But a lot of times this is acceptable too. Okay. So those are some examples of evaluating with functions and doing some operations with functions. I'll do some examples in the later videos of how to use Desmos to evaluate some of the functions, and how to use your calculator to evaluate functions.